Hi folks, we're going to take a look at 13a from page 553. So they want us to find the distance from this given point to this line in R3. So first of all, notice that this is a line in R3. Okay, so we can't be working with a normal vector. There is no normal vector to a line in R3. So what I'm going to do is just, instead of just applying the formula, let's just kind of review how we got to this formula. So in case you don't remember the formula, you might be able to figure it out. So we have this point A, and we want to find the distance to this line, okay? And in particular, that's the shortest distance, which is going to be one that's perpendicular to the line, okay? And the way we solve this is we took any point on the line. In particular, I might as well take the given point 3, 0, negative 1. Okay, this is negative 2, 1, 1. Okay, and we created a vector from one point to the other. Okay, and then what we did is we said, well, if we take the direction vector to this line, okay, and of course I can place that anywhere, so I can place that direction vector here, and what I get is these two vectors form a parallelogram, and this distance just represents the height of the parallelogram. Okay, so essentially our distance d is just the area of the parallelogram. Okay, so let's call this b. Okay, so the area of the parallelogram is just given by the magnitude of the cross product of these two vectors. So the cross product of BA with my direction vector, okay, which is here, 1, 1, 2, okay, and I'll divide that by the base of this parallelogram, which is just the magnitude of the direction vector. Okay, so let's start by finding BA. Okay, so what does that give us here? That gives us negative 2 minus 3 is negative 5, 1 minus 0 is 1, and 1 minus negative 1 is 2. Okay, and we're going to take the cross product with our vector m, which is 1, 1, 2. So I'll find the cross product here. So put the negative 5, put the 1, and the cross product is just going to be given by 2 minus 2 is 0. Okay, here we have 2 plus 10 is 12, and here we have negative 5 minus 1 is negative 6. Okay, so this is just going to be the magnitude of the vectors 0, 12, negative 6, the one we just found by taking the cross product, divided by the magnitude of the vector m, which is just 1, 1, 2. Okay, so of course if you've memorized this formula, that's great. If not, you know, you are able to generate it fairly easily if you remember this idea of the area of a parallelogram. Okay, so what do we have here? We have 0 squared plus 12 squared plus negative 6 squared over, this is 1 squared plus 1 squared plus 2 squared. So what do we have here? We have 144 plus 36, so 54, 64, 74. So that's going to be 180 over 4 plus 5 plus 1 is 5 plus 1 is 6, so square root of 6. And so here I can take these under the same square root, okay, by property of radicals. So here we just have square root of 30 units. Okay, and there you have it. So again, the idea is you need to have the point, and you need to have the direction vector of the line, but you also need the point on the line to create that second vector. Okay, so again, if you don't have the formula memorized, you might just remember how you generate that formula, which is fairly straightforward. Okay, that's it for this one.